In the last video, we encountered a situation where a source file had to be recompiled because a header file that it included had been changed. Tracking these sorts of dependencies is tricky. Also, when a project contains many source files and many header files, it can be difficult to remember which files depend on which other files. The compiler toolchain contains a tool called Make to help manage the compilation process. The project we have been compiling consists of 3 files: compare sorts and sorts, which are source files that need to be compiled and then linked, and sorts.h, a header file they include. Let's create a Makefile to build the parts of this project that need it. Makefiles are composed of a sequence of rules. Each rule has a target, the file to be constructed, and each rule also has a recipe, the command or list of commands to execute that create the target. If dependencies or prerequisites are present, the recipes are executed if one or more of the dependencies are newer than the target. If there are no dependencies, the actions are only executed if the target doesn't exist. Listen very carefully. The white space before the recipe is a tab, not just spaces. I guarantee you'll make this mistake at least once, so I'll just say "I told you so" ahead of time. This rule defines a target named compare sorts. Compare sorts depends on 2 source files. If either source file has been updated, then the actions are executed to rebuild compare sorts. Note that the file I've created is called Makefile. When I run the command make without arguments, it looks for a file named Makefile in the local directory and checks the rules it contains. In this case, it detects that there is no file named compare sorts, so it executes the actions for the compare sorts rule. If I run make again, it tells me that compare sorts doesn't need to be rebuilt, and nothing is done. The touch command updates the time that a file has been modified. In this case, it made it look like the file sorts.c has been modified after compare sorts was last built. So when I run make again, it is rebuilt. But the rule I've defined doesn't yet account for the header file, so make doesn't detect that it needs to rebuild the executable if the header file is updated. Also, we aren't taking advantage of separate compilation with this Makefile rule. So let's add some more rules to our Makefile. It wasn't exactly true that our executable depended on 2 source files. It actually depends on 2 object files. And now we need to add rules to build our object files. Each object file depends on the relevant source file and the sorts.h header file. Now let's see what happens when we run make. First, let's remove the object files. This should force everything to be rebuilt. But only compare sorts.o got built. That's because I have 3 separate rules with named targets in the Makefile. When I ran make with no command line arguments, make evaluated the first rule in the file. If I use a command line argument to specify a particular target, then it will evaluate that rule. The real power of make is that each time it evaluates a rule, it will first check all the dependencies, and if a dependency is also a target in the Makefile, it will evaluate that rule first before checking the dependencies. Let's modify compare sorts.c by updating its last modified time using the command touch, and we will run make compare sorts again. Make finds the compare sorts rule and checks each dependency. It finds the compare sorts.o rule and checks its dependencies. It discovers that compare sorts.c is newer than compare sorts.o, so it executes the recipe associated with the rule which updates compare sorts.o. Now it is finished checking the compare sorts.o dependency, so next it checks the sorts.o dependency, It checks the dependencies in the sorts.o rule and discovers that sorts.o is newer than both sorts.c and sorts.h, so it does not execute the recipe. Now that both compare sorts.o and sorts.o have been updated, if necessary, Make checks the modified times of these two files against the file compare sorts. Since compare sorts.o is newer than compare sorts, the recipe will be executed. Note that only the files that need to be updated are compiled. But that was a bit tedious. I don't want to tell Make what to build each time, and if I add extra source files, I don't want to have to create a separate rule for each one. Makefiles support wildcards of various sorts. I'll use this new rule to replace all of my source file to object file rules. In this situation, the %sign means that each object file that needs to be built depends on a source file of the same name. $less than is a variable containing the first name in the list of dependencies. $at is a variable containing the name of the target. So altogether, this rule checks any required object file and builds it based on a similarly named source file. I'm getting tired of removing the object files each time we do an example. So let's add a new rule that will clean up for me. The word phony indicates that clean isn't actually a file. It's just a legal target. So building the target clean executes the remove command. Then, the next make rebuilds all of the required files because clean is not a file. The actions are always executed when the clean rule is evaluated. Okay, one more improvement. Makefiles can include variables. This line defines a variable named obj files. Now, instead of needing to add to the list of object files everywhere, I can just update the variable when a new source file is added to the project. This is just an introduction to what Make can do. It's a very powerful tool that can be used to manage complex projects. For more information, check the manual for Make.